goal of this series of learning modules is to educate you, the Mason, in identifying areas that require flashing, the types of flashing typically used for masonry construction, and general guidelines for proper flashing installation. We will outline specific problems that occur when flashing is missing or improperly installed, and the implications for the industry and your employer. Although this module will focus on single-width masonry wall flashing, it is not a how-to video. This is part 3 of 3 videos on masonry wall flashing. The technical content of Flashing for Masonry is based on Building Code Requirements and Specification for Masonry Structures, or TMS 402 and 602, and International Building Code, or IBC. When we refer to the code in this training module, we are referencing these documents. For the purposes of this video, we will refer to 2 types of walls as single-width walls: drainage and barrier. In this video, when we refer to flashing installed in a single-width wall, we are referring to a drainage-type single-width wall. Drainage walls are partially reinforced walls with some open cores in the masonry unit. Drainage walls require flashing and weepholes to intercept and drain moisture out of the cores of the single-width wall. Barrier walls are solidly grouted walls and should have no open cores or voids. Barrier walls do not require in-wall flashing or weepholes. Both drainage and barrier walls will require coping flashing, which protects the edge of roofing and limits wind-driven rain from blowing up under the roof edge, as well as preventing moisture from entering the wall. Proper flashing details are critical in single-width masonry walls because there is less redundancy for drainage than in cavity-type walls. The cores of concrete masonry units must actually work like a drainage cavity. Moisture that penetrates the exterior face needs to flow downward through the open cores of the masonry units and be redirected to the outside, as in cavity walls. Flashing of single-width drainage walls will require the masons utilize either a common flashing weep system, similar to the systems we discussed with cavity walls, or a system designed specifically for single-width masonry walls. In the absence of a design detail and/or specification, the mason contractor should request information from the design team. It is in the contractor's interest to inquire about wall flashing, and especially single-width masonry wall flashing, because if the building later has leaks, the mason contractor is almost guaranteed to get a phone call from an upset owner, designer, or general contractor. Traditionally, single-width masonry walls have used a metal or flexible type flashing to ensure drainage of moisture from the cores. Let's look at this type of installation a little closer. Flashing a single-width drainage wall with metal or flexible flashing can be more challenging than flashing a cavity wall. Because the continuous airspace to channel moisture between the 2 widths is not present, the block cores must function in that capacity, unless a proprietary pan-type system is used. A space needs to be created at the flashing course to provide drainage by separating a single block course into 2 widths to accommodate flashing, weeps, and mortar control devices. The empty cores above the flashing course must serve as drainage channels. The back of the flashing should be bent to embed in the bed joint of the next course at the interior face. Drip edge should be installed and sealed under the flashing. Any splices of flashing should have a minimum of a 6-inch lap and be sealed per the manufacturer's recommendations, or soldered in the case of metal flashings. It is important to ensure flexible flashing is fully supported. End dams should be provided at the terminated ends adjacent to vertical reinforcing, as well as at ungrounded opening jambs, and at ungrouted areas where the wall meets dissimilar materials such as curtain walls. Each of these cases may require units to be cut to accommodate end dams and ensure a proper installation. It is important to ensure that all grouted cores are cross-webbed with mortar to ensure the grout does not fill the cavity created for the flashing, as it will likely fill the drainage area and clog weepholes. Locate weepholes and place them flat above the flashing. Ensure weep holes remain unclogged to allow moisture to escape from the completed wall. Mortar control devices will need to be installed as well to ensure weep holes remain functional. The locations for flashing in single-width drainage walls would follow the same rules discussed in Flashing for Masonry Part 1 and 2, but it is important to remember that flashing is required at all interruptions in the vertical plane of the wall, such as bond beams. Otherwise, moisture will accumulate in the walls, causing staining and potential damage. Install flashing above bond beam course in a similar fashion to the wall base installation. Since any opening in a wall is an opportunity for a leak, moisture protection at lintels is critical. If a steel lintel is detailed and flexible flashing is specified, use narrower units to create a space for the flashing. Place the flexible flashing over the lintel in a fashion similar to cavity walls, including a drip edge sealed to the lintel and flashing sealed to the drip edge. End dams should be installed at the end of the flashing. Mortar control devices and weep holes should be installed in a similar fashion as previously shown in cavity walls, with flashing tucked in the bed joint of the inner width face shell. At masonry lintels, the flashing should be installed in the course directly above the top of the masonry lintel. The masonry lintel can be one or more courses, depending on how it is designed by the engineer. Again, creating two widths and installing flashing in a fashion similar to the base flashing installation. Ensure end dams and drip edges are installed. It is important to ensure that any vertical cores that will be grouted directly above the opening lintel are sealed and isolated from the flashing drainage path. Otherwise, the drainage area will fill with grout, making it ineffective and prone to staining and leakage. Flashing should be installed below openings as well, including end dams, weep holes, and drainage material. This would be applicable in the case of a stone or precast concrete sill as well. In all these cases, the installation is very similar to what was described for cavity walls in Part 2 of this series. A thinner backup unit should be installed behind the sill to adhere the flashing to. Remember to ensure the flexible flashing is fully supported. Locate weep holes where directed by drawings and specifications. In addition to metal or flexible flashing systems, pan-type flashing systems are available for single-width drainage walls that direct water away from the inside face of the wall to weep holes without compromising the bond and mortar joints in the face shells. Typically, these systems consist of a drainage pan that incorporates a weep hole and a mortar control device to ensure the system remains unclogged. As with the metal and flexible flashing systems, pan-type flashing systems would be required at wall-based locations to ensure wall drainage. The pan is eliminated at grouted vertical cores, since voids and cavities where moisture can collect are absent in vertically reinforced cells. Further, end dams do not make up a part of most pan-type systems currently available. Mortar control devices supplied as part of the system should be installed over every pan after the next course is laid. This will prevent mortar droppings from clogging the weep holes. At steel lintels with a pan-type single-width flashing system, the units are installed around a steel lintel and the void areas are filled. The pans are placed at core locations, except where vertical reinforcing will be located. Mortar control devices are placed above the pans after the next course is laid to prevent clogging of the weep tubes. At masonry lintels, the lintel is placed as detailed and shored, and the pan system is placed in the same manner as at wall base, again with mortar control devices installed in the following course. Reinforced cores do not require a flashing pan. Because horizontal bond beams create a break in the downward flow of moisture, flashing must be installed directly above the bond beam course to prevent moisture-related staining and damage. Pan-type systems should be installed over the bond beam course, following the same installation process as wall base and window openings. Generally, the process of installation of pan-type systems does not change based on the location of the wall. Solidly grouted single-width barrier walls do not require wall flashing because they are not as susceptible to moisture penetration. since voids and cavities where moisture can collect are absent. An architect may incorporate a flashing design into barrier walls for various reasons, so it is important to review the details in design. Cap or coping flashings would still be required for barrier walls, and depending on actual sill conditions, flashing may be required below openings. A stone or precast sill and a fully grouted, single-width opening would require flashing and weeps. In the case of fully grouted barrier walls, special care should be given to ensure end joint conditions are filled solid as well, to avoid channels where water can accumulate and create staining or allow moisture in the building interior. In addition to wall drainage, top-of-wall conditions and single-width walls require the use of flashing. Masonry copings such as precast or stone will require a nearly identical installation as cavity walls. Install flashing with drips at exposed sides and seal all penetrations. Often single-width masonry walls will have a metal cap flashing detailed. This metal cap flashing is often not installed by the masons. The mason is usually responsible for installing the anchor bolts that are designed to bolt down the pressure-treated blocking. The cap flashing should be sloped to prevent water from draining onto the exposed surface of the masonry and should extend at least 4 inches over the face of the masonry, with a slope drip and sealed on both sides. It is important to ensure a smooth texture is used under the cap to ensure a relatively tight fit between the masonry surface and the cap. A tight fit might be hindered by uneven concrete masonry units such as split face or fluted units. Sealing the fit between the cap flashing and the wall is strongly recommended because wind-driven rain can push moisture up a wall 1 inch for every 10 miles per hour of wind speed. As an item to note, it is required by code that the top of walls be protected from moisture entering until the permanent coping is in place. Failing to protect the top of the wall has resulted in the most severe moisture-related staining of masonry. Uncovered walls are likely the #1 source of staining in job site disputes. Perhaps the most effective way to ensure that completed walls remain covered after the mason has left the project is to install an inexpensive membrane at the top of the wall upon completion. EPDM is inexpensive, can be glued to the top of the wall, and left in place below the blocking. Bolts and embeds should be sealed to ensure moisture cannot enter the wall from the top. This simple step can prevent the majority of problems mason contractors will ultimately have to deal with when moisture-related staining from uncovered walls begins to occur. Let's review problems created by lack of or improperly installed flashing. Walls without masonry flashing are inviting a series of problems. Single-width partially grouted walls will accumulate moisture in the cells, either from uncovered walls, shrinkage cracks, or condensation. The accumulation of that moisture will ultimately result in staining, moisture damage on the interior of the building, and possible freeze-thaw damage to the masonry units in the wall. Unsealed, poorly sealed lap joints, or laps too short to ensure proper sealing of the flashing are going to allow moisture to cause damage to the interiors, lintels, and backup widths of materials such as drywall, metal or wood studs, insulation, and other items relying on the flashing to function properly. Masonry sills without flashing leads to stained exterior walls, as well as potential interior moisture damage. Lack of end dams at opening flashing terminations, control expansion joints, and wall terminations will likely allow moisture to seep toward and around window door mullions, lintels, and interior spaces. Concrete planks are vertical interruptions of the wall. Failure to install flashing at the wall interruption of concrete plank will result in costly staining and moisture infiltration. This is a particularly critical item in single-width walls without a drainage cavity. Moisture-related problems will be immediate and will cause damage to interior spaces as soon as they become apparent. Covering completed walls and walls not currently under construction is a very effective way to prevent moisture from entering the walls. It helps to prevent moisture-related staining on new walls and ensures that additional moisture is not entering newly completed walls. This moisture can exist in small pockets at the top of vertically reinforced cells and bond beam and slowly migrate within the wall, creating the potential for efflorescence. Covering the walls not under construction is the first step in moisture control and is required by building code. Your contractor is going to get the call when staining and moisture-related problems start. Making sure that there are no flashing problems can help avoid calls to your contractor about the disappointing appearance or water-related damage. If you identify areas that are not detailed for flashing that should be, encourage your employer to write a friendly correspondence letter to designers to ensure that completed projects are the ones the designers remember and want to duplicate. Requesting a specific flashing detail for that area is the proper action. Even if it is not resolved, at least that letter is in hand 8 months later when there is a problem. An advantage of masonry is that we are a mature industry. Time has tested our wall systems. Whether a cavity or single width wall, there are no unanticipated consequences using masonry. We understand the design details that make for great performing walls. When they are built to code and industry best practices, owners can count on durable, fire-safe construction. The Upstate New York chapter of Mason Contractors Association of America operates in the spirit that if it's good for masonry, it's good for us all.